Previously, I showed how to write a filter function, and in this lesson, what I want to do is show how to write a map function. And recall that I'm doing all this just to show how to write your own higher order functions. So to get things started with, I created these functions up here. So this one's called double, and it doubles the input int and returns an int. This is called +1, and it adds 1 to whatever int is passed in. It returns an int. This one is toString. It takes an int and returns a string. And just in case we need it, let me throw one more in there. This one is called toDouble, and it takes an int input parameter right here and transforms that into a double. Then we come down here, we have a sample list that we can work with. And what I want to do in this lesson is write code like this. So we want to assume that the map method on the list class doesn't exist. So we want to write our own map function. So we can assume that it's going to take a list like xves, which is a list of int. So just to be clear, I could say that this is a list of int right there. And now I want to pass in a mapping function right here. And that gives us a good idea what our map function is going to look like. So let's come up here and do that. And that. And now this is going to return something here. So now what we're going to do is a very specific case. Just say, I just want to work with x of s as a list of integer. That's all this map function is going to work with is a list of integer. And then you can pass in a mapping function. And as we saw with the map function in the list documentation, map takes a function that transforms an input a, which in our case is going to be an int, into some other type b over here. So that's the type signature that the official map function expects for the function that's passed into it. So what we're going to say is, well, I'm going to get rid of that word mapping function because that's pretty long. I'll just call that f. And I'm going to say, well, ours is an int instead of an a. All I work with is int, so I'm going to do that. And then I need to transform that into something else. So I suppose we could call it b like that. And that looks pretty good. That matches that up there. And what you have to do when you work with generics is you just have to declare that generic type up here that way. So that'll make the compiler happy. And now a good question is, what do we put right here where I have these question marks? What do you think I should put right there? What is the type that the map function returns? And if you've worked with map before, you might know that, well, I could do a z of s and I'll say map, do that backwards, x of s dot map. And now I could transform these integers I into just about anything in the world. So I could transform it into a double like that. Or using my own functions, I guess I could say I could transform that into a double like that. Or I could transform that into a string and so on. So what happens is this type over here can be anything. And that means that this over here, cutting to the chase, since this is a list of int over here, this is going to be a list over here. And its type is going to be whatever you're transforming it to over here. So in this specific example, this would be transforming that into a string. But if this was toDouble instead, then this would be double right here. So those last two examples tell us that we could take that right there, and instead of being list of double or list of string, it's going to be a list of type B here, this generic type right here. So this little anonymous function right here transforms this int into a double. And the more general version of that is that it transforms an int into a b. And this transformation right here, this entire map on all the elements in x of s, results in a new list over here. So that's why we have a new list here. So I know I'm talking a lot, but basically map takes one list as input, it has this type, and returns another list of any type that you need over here. And that's the return type from map. And now, as you can see from this sort of example here, what map does is it marches over every element in x of s to produce this new result. So when you start thinking about marching over every element, then of course you want to create a for loop or a for expression in this case. And we want to say, well, for every element, or in this case, how about I'm using x of s up there. So I'll say for every x in x of s, what I want to do is there's not going to be any filtering. What I want to do is just yield some new value. So right down here, I want to do something to modify x and return something new here. And all you have to do to modify this value is to apply the function f to that value, right? F is the function that's passed in right there. So then we apply f to f of x, and that gives us our transform values. And that should be a map function. That's the entire map function, unless I made some sort of mistake. And I see a mistake there. So we can start with something like double. And then I want to do a print line on y of s and save that. And there we go. So I'm running this code right now with that Scala CLI command. And you can see, oh, sorry, I used the wrong function there. I used this double function, which transforms an int to an int. I was seeing this output here, and I was like, that's not right. That should be 2 double was what I had in mind. And now we see the right result out there. So this list now contains these double values. And the string I noticed in the earlier video probably has to be a little bit different. So we say something like the value is like that, and come down here and change that to a string and save that. And now you can see strings inside of here. As I mentioned before, the compiler does not include double quotes here, unfortunately, but you can see that this is a string, that's a string, and that's a string. So in this example, what I did was I showed how to create this map function, and we did that by passing in this function right here. And now what I want to do is make this a little more general purpose. So imagine now that we had another list, and we'll call this one A's, and that's going to be a list of, how about string like A, BB, and CCC like that. And now what I want to do is create val BS equals map on AS, and then some function in here, some function that can handle a string as an input and transform that into something else. So now when I come to map here, instead of just taking this list of int, I want to take in a list of anything. And the way we do that is we just change that to an A right there. Then, as I mentioned before, I have to put an A there. And now, because I'm not working with a list of int here, I'm working with a list of anything. Now I need to take a function that transforms anything A into anything B, just like that. And unless I made any mistakes, that should work just fine. So now we could say, well, and now I'll just use an anonymous function here and just say, well, I'm getting a string and I want to transform that into the string length right there. So just to avoid any confusion, I will comment that out and save that. And as usual, I forget to print things. So we'll save that. And there you can see the length of the 3 strings should be 1, 2, 3. And just to verify that, I will do something different. And there you go. So now we have a general purpose map function. It works on any type of list, and the function it takes transforms any A to any B. And that's very cool because that is really generic. And the last improvement I would make is instead of using a list here, we should use something else, right? Because I could change this to a vector and save that. And you can see that does not compile. And it's saying that in this code right here, it is finding a vector of string, of course, because that's what this is. And it must require a list of any. So the problem is not with generics now, it's with the vector and this list here. So in Scala, what you do is you just go a little higher up on the hierarchy and say, well, seek is a parent of list, and it's also a parent of vector. So I can change both of those to seek and press save. And now that's pretty cool, isn't it? Now we have a very generic version of a map function right there. So I hope this has been helpful. I'm primarily trying to show how to write a map function and other functions that take in function input parameters like this right here. And in the process of writing this one, I also got into generic types a little bit. So now we can take in a generic sequence of any type there, and then we take in a generic function that transforms any A into any B. One thing I should note also is that The implication here is that A and B are two different types, but really you should say that they could be any two different types, and they could also be the exact same type. So I could just change this to a string here and say the string equals $S and save that. So again, you see this output down here. And the only reason I did that is to show that A and B, as shown here, can be any different type. So A could be a string, B could be a double or an int or a float, but A and B could also both be strings, as in this example right here and with this output right here. So I just wanted to show that, to be clear about that point, that A and B can be different, but they don't have to be different.